Hello, welcome to lesson 2 for our course Chemistry 301 SW, which is Analytical Chemistry. Today, our focus will be on evaluation of analytical data. I hope you enjoy the lesson. In this lesson, we are going to introduce ourselves to what we mean by evaluation of analytical data, what measures of central tendencies are, what constitutes measures of spread. Once we have done an experiment, how do we characterize errors that occur? We also look at propagation of uncertainties. This should make up for lesson 2 of our course for this semester. Last week, we looked at the language of analytical chemistry, where we made mention of certain key terms or words like precision, analyte, analysis, method, procedure, protocol, calibration, standardization. I hope you remember all these terms and what they stand for or mean. Our concentration today, however, would be on after we have collected data as a result of an experiment. How do we put meaning to the data that we get? So, the process of trying to give meaning to the data at hand is what we are saying to be evaluation of analytical data. In other words, to evaluate an analytical data is more of trying to make sure that the results that you have are accurate and you can rely on them. To be able to rely on results, you have to assess whether they are of quality. The results that you have, are they valid? In terms of the data that you have, is this significant? Can you make meaning or conclude based on the data that you have? Should the data that you have be able to help you form or inform decisions? That is, if you are trying to solve a certain problem or finding out the constituent of a sample. To begin any evaluation of analytical data, you need to look at your experimental design and the method that you are using. So, examining your experimental design and your methodology has to do with a series of steps. You could have sample collection, how to prepare the samples, how you are going to store these samples, how you'll be able to select your instrument, the kind of instrument that you are supposed to use to determine any, for example, the concentration or amount of substance in a sample. Once you are able to go through these things, at the evaluation stage, you are looking at calculating means of any data given. How are the values you have deviating? How confident are you of the values you have? If you have any hypothesis before you set out, how are you going to test it? All these things should be looked at before you start with your evaluation. Now, in terms of evaluating your set of data, you are also trying to look out for values or figures or answers in the data that are different from the set of data that you have. Different here meaning that it's an anomaly. It's not normal. Now, once we see that there is an outlier or something is different, in this context, we are giving relevance to the results that we have. We are giving importance to the results that we have. So, to evaluate analytical data, you need a rigorous and systematic examination of the data that you have collected. You'd have to use some validation processes and critically assess what you have. Overall, we are doing this to ensure that there is reliability, accuracy, and that your results are significant. Once you are able to do all these things, you'll be able to make good decisions. Now, let us look at some of the things that we do when we are evaluating data. Now, let us look at some of the things that we can use to evaluate our data. The first one we are looking at is measures of central tendency. So just like this name is saying, central. Central here we are referring to the middle point. The middle point. So what we mean by measures of central tendency is that we are just looking at the set of data, finding the midpoint, the center of it. Once we are able to do that, we are saying that we are able to provide a summary of the data that we have collected by identifying a certain value or figure which is in the middle that can be used to represent the data that we have. There are three common measures of central tendency. We have mean, median, and mode. Let us look at them individually. Now let us look at the term or the word mean. When we say we are finding the mean of data, what it means is that the number of data or the number of individual values that you have, you are going to find the average of those set of values. Now, how do you find the average? You find the average by adding up all the values together. That is, you sum it up. After you have done that, you count the number of individual values that you have. Then you add it, which is the total. After you have done that, you divide the sum of the values by the number of the set of values. Now this is what we mean. We assuming that the values that we have is 1, 2, 3, 4. If we are to find the average, what we do is that we would add all these numbers together. That is 1 plus 2 plus 3 plus 4. 1 plus 2 is 3, 3 plus 3 is 6, plus 4 equals 10. Once we have added all the values, we then divide it by the sum. We divide the sum by the total number. So how many numbers do we have here? 1, 2, 3, 4. Then we divide the total here by 4. The value that we get is what we are saying to be the mean. Now let us look at this example. This data set has a score of 480, 90, 85, 95, and 100. To find the mean, what we need to do is that we are going to add 80 to 90 to 85 to 95 and then to 100. When you add all the numbers together, you are going to get 450. That will be your sum. How many values or numbers of the test score do we have in the data set? So we can count them. 1, 2, 3, 4, and 5. Once we know that n is equal to 5, what will the calculation be? We will divide our sum, which is the 450, over our number, which is the 5. That should give us 90. Hence, our mean then becomes 90. Hope you get the calculation very well. Okay, here is an example for you to work or try your hands on. You have the class A and the class B. Each class contains a certain set of values. For example, class A, you have 17, 10, 9, 14, 13, 17, 12, 20, and 14. I want you to calculate the mean for this set of values. I hope you remember the process or the procedure. You add all the individual values, then you divide by the total number of values contained in the data set. Very good. Now try your hands on before we move on to the next term of central tendency. Now let us look at the term median. Remember that we have already talked about a data set. Now we are saying that for median, once you would have a set of data, when you line them up, the center or the value that is at the center, the value that is in the middle, or the value that separates the left hand side of the data and the right hand side of the data is what we are terming to be the median. Median in the sense that it is in the middle portion. That is when the data is there. It's right in the middle of the data. Now, how do we find the median of the data set? Here, the simple rules are that you first have to put the data in an orderly manner. That is, from the smallest to the largest. Once you are able to arrange this data set in this manner, you then determine which value is in the exact center. So for instance, you have A to Z as our set of data. Which data sits just in the middle of the values from A to Z. If it is M, then we are saying that M becomes our median. Now this situation works when the value or the set of data in terms of the numbers are odd numbers. That means that when you look at one half of the set of values and the other half of the set of values, the median will sit right in the middle. However, in terms of the number of data sets, it's an even number. The median then would become the mean of the two numbers that lie in the middle. This is what we mean. You can have 1, 2, 3, 4. You realize that when we count these numbers 1, 2, 3, and 4, it's an even numbered data set. So, to find the median, we are looking at these 2 and 3, which is in the exact middle. That is, there are two numbers. So what we do is that you would add 2 to 3 to get a value of 5, after which you divide it by 2, which will result to the value 2.5. And this 2.5 value becomes the median of the data set that I have used as an example. Let us consider this data or as an example. Now when you look at this set of data, what do you see at the first glance? Here we are looking at the first value to be 17, second value to be 10, third value to be 9. Remember what we said about it? That is the first step that we are supposed to do when we find this set of data. We have to put the data in order. That is, from the smallest to the largest. What is the smallest value in the data set that we have? Readily we can see that it is the value of 9, which is the smallest. Which is the largest value? We are looking at number 20. So when we are arranging, we are going to arrange from number 9 upwards to number 20. Now, after we have placed the values from the smallest to the large, you realize that now our data set has been rearranged. 9 being the smallest begins our data set, 20 being the largest ending our data set. Now let us look at the next step. We will have to count the individual values in the data set to determine whether they are even numbered or odd numbered. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is an odd data set. Once we are able to identify that it's an odd data set, they mean that the number or the value that lies right in the middle becomes our median. Now let us count. If it is 9, it means that there should be 4 values on each side of the median. So 1, 2, 3, 4. Very good. 14 becomes number 5. Let's count from the other side. 1, 2, 3, 4. Very good. What number then lies in the middle? It is number 14. Hence, number 14 becomes our median. Consider this data set A and B. Determine the median for the sets of data. Give yourself some 5 minutes to go over this example. Are you able to do it? Very good. Now, let us look at this term mode. For evaluation of analytical data, we use the term mode to define values, figures, numbers that appear more than any other values in a set of data. For example, if you have numbers or values 1, 1, 2, 3, 4, how many or which number appears more than any of the numbers here? You can say that number 1 appears twice and it appears more than any other value. Based on the frequency of how the number 1 appears in the set of data, we would say that the mode for the set of data is 1. Now, you should note that you can have one number appearing more than any other number or value. When that happens, we are saying that the set of value or data has only one mode. If all the numbers in the set of data appear the same, whether it is once or twice, we are saying that there is no mode. Or if every number occurs only once, then there is no mode. However, if one set of number occurs more frequently, we say that there are multiple modes. For example, 1, 1, 3, 3, 4, 4, 6, 7, 8. When you consider this set of data, you realize that the numbers 1, 3, and 4 appears more than once. They appear in the same frequency of happening twice. When this happens, we are saying that there is multiple modes. That is, one number is occurring more frequently. In this example, which numbers are occurring more frequently? Numbers 1, 3, and 4. Note, we are saying that if you want to determine the mode, there are 3 steps that you are supposed to take. Number 1, you are supposed to put the data in order from the smallest to the largest. Remember that we did same for median. The second step is that you look for the values that occurs more than once. First one, put them in order from smallest to largest. Step number 2, look for values that occurs more than once. The third step is that you are supposed to determine which of the values that you have identified occurs more frequently. That will be our step number 3. Now let us look at an example. Let's look at this example. Given a set of data which contains these values 17, 10, 9, 14, 13, 17, 12, 20, and 14. Find the mode. Do you remember our steps? The first one is to put them in order, smallest to largest. Now, let us rearrange these numbers. So when we rearrange the numbers, we are going to have 9 as the smallest, 20 as our largest. And the second step is to look for the numbers that occurs more than once. Going through the set of data, what numbers can we identify? So we have 9, 10, 12, 13. We have 14 and another 14. Okay, so we can cross this once. 17 and 17 has also repeated itself. So 17, 17. We have now been able to identify the numbers that occurs more than once. This number is 14 and 17. So between 14 and 17, which of the numbers occurs more frequently? So we realize that they all occur twice. And if you want to know our mode would be numbers 14 and then 17. What do we call numbers or values that repeats more than once? When we go back to our previous slide, we are saying that they are multiple modes. I hope you get the concept. Very good. Here is an example for you to work on your own. The question says, from the data set of color for a group of flowers, and here are the colors: red, yellow, blue, red, red, purple. Find the mode. The second example is that suppose we have the following data set of numbers: 10, 20, 30, 20, 30, 40, 50, and 40. Determine the mode of the data set of numbers. Now let us look at this new set of terms. This set of terms fall under what we call measures of spread. Just like the name suggests, we are going to be looking at how far or near a set of data are spread or how far apart they are. So you would see an important word like variability. When we say variability, what we mean is that how far or how spread is a set of data, or the degree of variation within a set of data, that is spreading of a certain data set. Now, how does it help us to give meaning to our data? We are saying that it's going to tell us or show us how our data that we have collected is dispersed or scattered around our central tendency. I hope what you remember what central tendencies are. We are looking at what? Very good. It's good that you have been able to recollect those ones. Mean, median, mode. Very good. Under the measures of spread, we are going to be looking at some key terms like range, variance, and standard deviation. Now let us look at this keyword, range. When we talk about a range, which is represented by a W, we are saying that when you pick a set of data, the difference between the largest value and the smallest value determines the range. For example, we are saying that you have 1, 2, 3, 4, 5 as a set of data. Which would be your largest? Which would be your smallest? Our largest would be 5, smallest would be 1. When we take the difference of 1 and 5 would have a value of 4. 4 then becomes our range. The range we are saying gives us an information about how spread the data set is. Now, in order to determine a range, when given a set of data, we first have to identify the largest value. We call that largest value the maximum. Then, we identify the lowest value in the data. Let us call this lowest value as our minimum. What then do? We will subtract the minimum from the maximum. In mathematical terms, we are saying max minus min. Very good. Let us look at this example. We have a set of data 17, 10, 9, 14, 13, 17, 12, 20, and 14. What is the first step that we have to take? You realize that the numbers are not in order. So to make it easier for us to identify the largest and then the smallest, we will have to rearrange the numbers from the smallest to the largest. Can you identify the smallest? Yes, the smallest would be 9. What about the largest value? Our largest value here would be 20. So rearranging them, you are going to move from 9 to 20. Once we have rearranged them, we have to identify the maximum value. So we've already arranged them from the smallest to the largest. Automatically 20, which is the last number, becomes our maximum. The first number on the list becomes our minimum. Then we would then subtract the minimum from the maximum. Minimum is 9, maximum is 20. Mathematically, it is expressed as 20 minus 9, which gives us a value of 11. The range of this set of data is 11. I hope you're able to follow the concept. Very good. Let us look at this example. Assuming that we have a set of data 25, 26, 24, 27, 23, 28, 22, which represents data set of temperatures taken of a patient. The first thing to do is to rearrange from the smallest to the largest. Smallest here, what can we identify the number? 22. Very good. What will be the largest number? 28. It means that we are going to arrange from 22 to 28. So 22, 23, 24, 25, 26, 27, and the largest 28. Once we are able to identify the largest and then the smallest, what do? We subtract the smallest from the maximum. So it will be 28 minus 22, which will give us 6. Then our range becomes 6. Very good. Look at the second example. Remember the steps we took before we are able to identify the range. Go through those steps and then identify the range. The next one to look at is standard deviation. When we look at standard deviation, let us first look at what it means. We are saying that when we look at the keywords or the terms that we initially look, which is the central tendencies. We talked about mean. Now, standard deviation here is about how the individual values in a set of data is around or spreads around the mean of that set of data. In other words, mathematically, we are looking at the square root of the variance. And that is going to provide us with a measure of spread which is similar to the variance. So looking at this mathematical equation, we are saying that the square root of, when you look at the numerator side, the summation of the square of the individual values where we have subtracted the mean from it, divided by the number of the set of data minus 1. Let us look at what it means through an example. Now let us look at this example. We have to determine the standard deviation of the following set of data. The values in the data are 3.056, 3.080, 3.094, 3.107, 3.112, 3.174, and 3.198. Do you remember what we are supposed to do in order to find the standard deviation? The first thing that we are supposed to do is to find the mean. Once we are able to find the mean, what we do is that you subtract the mean from the individual set of values. Those values that you get, you don't forget to square them. That will be a numerator. After you square the values that you have gotten after subtracting the mean from the individual values, you have to put them all together, sum them up. Once that becomes your numerator, the denominator would be subtract 1 from the number of the set of data. Once you are done with that, you can find the square root of this expression. This would be our standard deviation. So let us look at how this example pans out. So to find the mean of the data set, we are going to add all the values that are in the data set. It's giving us 21.821. How many values are there? We have 1, 2, 3, 4, 5, 6, 7. So we then divide the sum of the total values over the number, which is 3.117. And 3.117 is our mean. Once we have the mean, it means that we have to subtract 3.117 from the set of the individual values. It means that 3.117 would be subtracted from 3.056, sorry. That same mean would be subtracted from 3.080, 3.094 until we get to 3.198. After you have subtracted the mean from the individual values, this is what is getting us. We are not done yet. The step 3 is to square the resulting differences. Means that the first value, which is minus 0.037, we will have to square that value, which is giving us this. So we do that for all the 7 resulting values that we got. Once we are able to square those individual values, the total of the values becomes 0.01554. That will be our numerator. Then, how many values are in the data set, which is n? N is given as 7. So we subtract 1 from the number 7. So 7 minus 1, which will give us 6. Once we are done with that, we divide the numerator from the value that we have gotten for the denominator, which is 6. And the value would be given as 0.002592. Once we have such a value, we can then do the final step, which is to find the square root of such a value. The square root of such a value then becomes 0.0509. That value is our standard deviation. I hope it wasn't confusing. Now let us try our hands on this question. We have values 17, 10, 9, 14, 13, 17, 12, 20, and 14. How do you go about finding the standard deviation? Remember, we have said that the first step is to find the mean. The second step, you can subtract the mean from the individual set of values. Once you have done that, you square the values that you obtain. After you square the individual values, you sum them up. That will give you the numerator. The denominator of that said equation then becomes the number of values in the set of data minus 1. Once you are able to obtain that, you divide the numerator by the denominator. The value that we get, we then find the square root of such a value. That will give us the standard deviation. Work it out and let's see the answer that you got. Now let's look at variance. Variance here means that mathematically you are just finding the square of the standard deviation. However, in plain terms, what we are seeking to do is to measure how the data is spread out around the mean. And I've already said that in mathematical terms, it is just squaring the standard deviation. Let's look at this example to help us better understand the term variance. Let's find the variance. We have a data set of 3.056, 3.080, 3.094, 3.107, 3.112, 3.174, and 3.198. When you consider this set of data, the first thing that you are supposed to do is to find the mean. Once you are done with the mean, you should be able to calculate for the standard deviation. Now, this question or this set of data was given under standard deviation, and the value was calculated to be 0.051. Once you have that, from the concept that we discussed in the previous slide, you only need to square the standard deviation, which has been given to us as this. So s squared. S represented the standard deviation. So it will be 0.051 all squared, giving us a value of 0.0026. I hope it's straightforward and a bit clearer. As we have already discussed, during experiments, we are bound to make errors. Errors that are conscious or unconscious errors. Conscious not in the sense that we are intentionally trying to make these errors, but these errors are going to arise as a result of not being able to do one thing or the other. In characterizing experimental errors, let us admit that errors can occur at various stages of the analysis process. When errors occur, you realize that the results that we would obtain might lack some accuracies, might be inconsistent, and the uncertainty around it would be a bit high. To be able to identify these errors is very important as it will lead to high reliability and validity of our data. In trying to put into context the errors that might occur, we first need to ask ourselves if our measure of central tendencies is in agreement with our expected value or the true value. The second one is to ask ourselves if the data that we have obtained are scattered around the central value. If they are, why is it so? To put this into context, we are saying that errors can be associated with central tendency. Now, these kind of errors are likely to affect in the accuracy of the analysis. Precision-wise, errors that are associated with the spread is going to be affected. In terms of the types of experimental errors that are likely to affect accuracy and precision, can be categorized into determinate errors and indeterminate errors. Here, we are saying that accuracy are likely to be affected by determinate errors, while indeterminate errors affect precision. Let us look at an overview of what we have just said. In simple terms, when we categorize errors, we are looking at how it affects our accuracy and how it affects precision. Accuracy are likely to be affected by determinate errors, whilst precision is likely to be affected by indeterminate errors. What kind of errors would fall under determinate errors? We are saying sampling errors, errors that would arise as a result of using a wrong method, wrong measurement, could be due to personal errors. In terms of indeterminate errors, it could be systematic, random, or as a result of an error emanating from the instrument that is being used. Now let us look at some of the errors that are likely to affect accuracy. To put accuracy into context, we are saying that it is how close a value is to a measure of central tendency. That is, the measure of central tendency as compared to the expected value. We've already talked about what constitutes or what are the things under central tendency: mean, median, mode. So in this instance, if we are to express accuracy as an absolute error, it's going to be the mean or median of a set of values minus the value that we expect to have. Let me go over that again. P that will represent the absolute error would be equal to mean or median of a set of values minus the expected. Determinate errors. We've already discussed that determinate errors affect the accuracy of our data. We can have some kind of errors under these determinate error in terms of categorization: sampling error, method error, error arising from measurements, and personal errors. The source of these kind of determinate errors has specific magnitude and sign. It can be positive and it can be negative. It could be larger or smaller. No matter how this pans out, overall it's going to affect the accuracy of our result. This will end our first part of this lesson. I'll continue this lesson in the next video. I hope you remember all that we have discussed so far. Stay tuned and continue to work on more examples. Thank you and see you again.